the bees.
Hey! Haven't you ever heard of Save the Bees?
Actually, I heard the honeybees are doing just fine.
What do you mean? I thought we were dying.
No, actually, honeybees have been domesticated and pretty much over-industrialized. It's the other 20,000 bee species that are suffering. There's even a way to reduce the need for honeybees by making hiveless honey through a process called
Precision fermentation. Bruh, what is that?
I don't know. I'm no food scientist. Did someone say food scientist?
Precision fermentation is an emerging technology that involves using enzymes derived from microorganisms such as bacteria, yeast, and molds to transform complex compounds into simpler functional bioactive compounds. Precision fermentation can be applied to production of honey without the need for Apis mellifera, honeybee populations, offering an alternative in response to environmental bee concerns. We can use it to create honey more efficiently and save the bees, but not in the way you think. The honeybees have suffered from stress and colony collapse in recent years, but honeybees are domesticated and are actually negatively affecting the biodiversity of 20,000 other bee species due to high demand of honey. Precision fermentation of honey can help alleviate these issues.
You came out of nowhere. But go on.
Traditional fermentation is a process that has been around for centuries as a method to preserve and increase nutritional value in food. One of the earliest instances of fermentation goes back to 1700 to 1100 BC with production of honey wine. The introduction of precision fermentation came about in 1982 when the first precision fermentation-derived protein, a recombinant human insulin produced by E. coli, was presented by a biotechnology company. Basically, scientists found a way to make a human insulin using bacteria. And today, although not mainstream, some companies are using precision fermentation to engineer microbes and replicate metabolic processes that occur in a honeybee's stomach to make hiveless honey.
What's an engineering? I'll tell you if you listen.
Engineered microbes are acquired by first identifying the enzymes required for producing honey. This includes products like diastase and invertase enzymes. These are hydrolytic enzymes that are secreted by honeybees to ripen nectar and provide honey. From here, precision fermentation occurs by 1. Creating a string of DNA that contains instructions for producing the desired product and inserting the strand into the DNA of a microorganism, aka the production host. And 2, the modified host is placed in a bioreactor in ideal conditions. 3, once the enzymes are produced, the product is removed from the host and growth medium, then purified, and finally tested for contamination. Now we have what is needed to create honey. Natural honey has amino acids, vitamins, minerals, iron, zinc, and anti-inflammatory, antioxidant, and antibacterial benefits. Leveraging engineered microbes to produce enzymes and sugars that make up natural honey can ensure nutritional equivalence and familiar flavor.
According to my research, precision fermentation of honey that meets food safety standards and consumer preferences presents a feasible solution to the demand for sustainable and ethical food production. There may be challenges with optimization, affordability, and scalability, but this advancement promotes scientific ingenuity over commercial interests while addressing environmental concerns. It would be efficient for honey production while also being sustainable and environmentally friendly. Isn't that sweet? Yeah, now that I think about it, more research on improving the flavor profiles and texture to more closely mimic natural honey and make it a desirable alternative would be beneficial. We can apply this research for other sweeteners as well. Save the bees. Oh, save the other bees. Be the change.
Good one.